Welcome to video 2 of Databricks ML Associate Exam Prep Series. Today we are covering two major platform features, Databricks AutoML and the feature store with Unity Catalog. Both of these are heavily tested on the exam, especially the feature store. So let's get started. We'll begin with AutoML, what it does, how it works, and the specific advantages the exam asks about. What is Databricks AutoML? So Databricks AutoML is an automated machine learning tool that trains, tunes, and compares models with minimal code on your part. It automatically handles feature selection, data pre-processing, and algorithm comparison. You can point it at your data and tell it whether you are doing classification, regression, or forecasting, and it will do the rest for you. But here is what makes Databricks AutoML different from other AutoML tools. And this is a key exam point that you should remember. It generates editable notebooks. So you can see every single step it performed and you can modify any of those steps. It is not a black box, to be frank. All trials are tracked automatically with MLflow. So you get a full experiment history with logged parameters, metrics, and models. How AutoML actually facilitates model and feature selection? Let's dive in. The exam specifically asks how AutoML facilitates model and feature selection. Here is the answer. AutoML tries multiple algorithms like random forest, XGBoost, logistic regression, and many more against your data. It automatically engineers features, applying one-hot encoding for categorical variables, imputation for missing values, and scaling wherever it's appropriate. It performs hyperparameter tuning across all candidate models. Then it ranks every model by the primary metric, F1 score for classification, RMSE for regression, or whatever you specified using the validation data. The result is a leaderboard showing all the runs sorted by performance. You can instantly see which algorithm and which hyperparameter combination performed the best. And the generated notebook for the best model becomes your starting point for further refinement. You can tweak the feature engineering, adjust the model, or add custom pre-processing. On the exam, when they ask how AutoML facilitates selection, the answer is it automates algorithm comparison, feature engineering, and hyperparameter tuning, then presents a ranked leaderboard. So what are the advantages of AutoML? Let's see. The exam also tests the specific advantages of AutoML. Let me walk through them. Firstly, it reduces time to first model from days to minutes. Instead of manually trying algorithms, you get a working baseline almost instantly. Second, the baseline is strong. It provides a benchmark to beat with custom models. Third, and I can't stress this enough, it's transparent. Many AutoML tools are black boxes where you can't see what actually happened under the hood. Databricks AutoML generates full, readable, editable notebooks. This transparency is a major differentiator and a common exam answer. Fourth, it democratizes machine learning. Analysts and less experienced users can build legitimate models without deep expertise. Fifth, it reduces human bias in algorithm and hyperparameter selections. We all have our favorite algorithms, but AutoML objectively compares all of them. Sixth and the final advantage, it integrates natively with MLflow and Unity Catalog. So all your results are properly tracked and governed from the start. Now let's move to the feature store. This is one of the most heavily tested topics on the exam. So please pay close attention to the specific API methods and the distinction between account level and workspace level tables. So what are account level versus workspace level feature tables? Let's dive in. The exam specifically asks about the benefits of creating feature tables at account level in Unity Catalog versus the workspace level. Account level feature tables which live in Unity Catalog are shared across workspaces. This means different teams in your organization can discover, access, and reuse the features without obviously duplicating the work. You get centralized governance with fine-grained access controls, feature lineage tracking, and discoverability across the entire organization. Databricks recommends this for the production use. On the other side, workspace level feature tables are the legacy approach. They are scoped into a single workspace, which means limited sharing between teams, less governance, and no cross-workspace discovery. Databricks is actively deprecating this approach in favor of Unity Catalog. On the exam, whenever a question asks about feature table benefit, the answer almost always involves Unity Catalog and cross-workspace sharing. Now, here is where the exam gets into API specifics, and there is a critical distinction you need to know. You use the feature engineering client, not the feature store client. The feature store client is old, the legacy API. The feature engineering client is the current one that works with Unity Catalog. This shows up directly on the exam. In fact, one of the sample questions tests exactly this point. To create a feature table, you instantiate the client with fe equal to feature engineering client. Then you call fe.createTable with 3-level Unity Catalog name, catalog.schema.table name, along with primary keys and optionally a data frame for the initial data. To write additional data, you call fe.writeTable with a table name and a new data frame. Under the hood, what happens is these feature tables are actually delta tables stored in Unity Catalog. The primary keys are required because they enable point lookups during model serving. So this is how actually the system retrieves features for a specific entity at the inference time. Remember, feature engineering client, not feature store client, and create table, not register table or alter table. The sample exam question confirms this. Once you have a feature table, how do you use it for training and scoring? For training, you called fe.createTrainingSet. This method automatically joins your feature table with your labels data frame. Then you specify which features to look up, which column contains your label. The beauty here is that the model logs which features it used. This metadata enables automatic feature retrieval at the inference time. For scoring, you call fe.scoreBatch. This method automatically looks up the features that the model needs using metadata logged during the training. You don't need to do manually join for features. The model already knows what it needs. This is a powerful pattern that we are looking at here. The feature lookup is defined once during the training, and then automatically it gets replicated during the inference. It actually eliminates a whole class of bugs where the wrong features or wrong transformations are applied at the serving time. Coming back to the last feature store concept that you will face in the exam is the difference between online and offline feature tables. Offline feature tables are the default ones. They are stored in Delta Lake, which means you do the batch access. You use them for training, where you need to process the full historical data set and for batch inference. They offer high throughput, but higher latency. Full historical data is available, which is actually essential for training purposes. On the other hand, online feature tables are stored in low latency key value stores. They are actually designed for real-time model serving, where you need features in milliseconds. The trade-off is lower throughput, and they only store the latest feature values, not the entire history. You need to explicitly publish features from offline store to the online store. When the exam describes a real-time serving scenario and asks where features come from, the answer is online feature tables. When it's about training or batch inference, it's always offline tables. Let's lock in the key points from this video. AutoML generates transparent, editable notebooks with automatic algorithm and feature selections. Everything is tracked in MLflow. For the feature store, use FeatureEngineeringClient and not the feature store client with Unity Catalog. This is the single most common trap in exam questions about the feature store. Account level feature tables in Unity Catalog enable cross workspace sharing and centralized governance. Online tables serve real-time inference. Offline tables serve training and batch inference. And create training set and score batch automate feature lookup using model metadata. So with that, the video 2 is done. You now understand AutoML and feature store with Unity Catalog. Next up is video 3, where we will do a deep dive into MLflow, the experiment tracking, model registry, and how to manage models with tags and aliases. This is another heavily tested area. So see you in the next video. Thank you.